So here's a fun fact from physics. The amount of force, and I'll use capital F for force. Oh, that's pretty good alliteration. Fun fact from physics. So the amount of force to compress a spring is directly proportional. So that means a constant times whatever comes next. The distance, and I'll just call that x, the spring was compressed. So basically you have the force equals a constant times the distance x. So that is the fun fact from physics. Now to find out what K is, that really depends on the spring. If the spring is made out of some cheap, very thin metal, it's not going to take very much force. It could be made out of steel. Maybe it would take more force. So for this one particular spring, it took 12 pounds of force to compress it from its natural length of 3 feet to 2 feet. So in other words, if this is the spring and at the top it's 3 feet, and then somebody compresses it using 12 pounds of force, then it's going to compress down to be 2 feet. So that means that x is equal to, it got compressed by 1 foot. So then just substitute that in, that the force is going to be a 12, and that the x is going to be a 1. So 12 equals k times x is a 1. Oh, well that's easy to solve. That means that k is equal to 12. So that means in general the function is going to be f equals 12 times x. All right, that's the first part. And then, let me clean some of this up. And then my question was, how much force would we be required to compress that spring down to 1 foot? So if you went back to the original spring, which is right here, and you're going to squish it down from its original 3 feet down to 1 foot, well, that means that x now equals 2 and feet. Another thing to keep in mind with word problems is the units need to be the same. All of these are using feet, so all of that's good news. So I don't have to do any conversions. So then just plug in the 2 feet, that x equals 2 feet. So the amount of force is going to be 12 times 2, which equals 24. And the units for that was pounds. So this would be 24 pounds.